Hi, welcome to Real Learning Center. Today we are going to start a new set of two videos basically talking about 2D motion. So when I say 2D motion, I mean basically going in two different dimensions. So we are going to basically talk about two kinds of 2D motion. One of them we call projectile motion, the other one we call a circular motion. There are many different kinds of 2D motions possible. Okay, these are the two things that we are going to discuss because they are very often used in our normal day-to-day circumstances. So let's start with understanding what is 2D motion, and then we get into projectile motion, and then later get into the circular motion. Okay, so let's start with understanding first of all identifying which is 2D motion. Okay, I will now here put across a few situations and find out or explore about thinking which one of them is a 2D motion and which one of them is a 1D motion. Okay, so there are two dimensions here, one x-axis, one y-axis. So I'm going to make a claim that something which actually moves both in x-axis and y-axis is called a 2D motion, in the sense that it value as the time progresses, the value of x coordinate and y coordinate, both of them changing, will be basically 2D motion. Otherwise it is 1D motion. So that is what I am going to basically talk, and let us see whether that is true. Okay, so let's start with let us identify that. The first one is actually it went straight like this from left to right, and you saw only x coordinate is changing, no y coordinate. Hence it is 1D motion. It is not 2D motion. So let's call it as 1D motion. Now let's look at the second one. The second one is like this. You can see it's actually a kind of jumping around, going like this. So it is moving both in x-axis and in y-axis as the time progresses, and hence it is 2D motion, correctly identified. Now let's look at the other one, the next one. Okay, let's see what it is. So see how the ball goes down like this and goes up. So it is what? It went in x-axis and it also went in the negative y-axis, and still it is progress as the time progresses, both x and y-axis are changing, and hence it is 2D motion. What about this? The next one. The next one actually is, you can see that it is going around in a circle. Okay, so going around in a circle also is a 2D motion because both x and y are changing as the time progresses. Now I'll show you one more thing. So watch this. So this already we said the circle is actually a 2D motion. So the next one is this one. So is x and y, are they both changing? Are x and y changing? X is changing, y is changing. So is it a 2D motion or a 1D motion? It went straight like this. So it actually appears to be a 2D motion because x and y both are changing. But actually we have never talked about what should be the x-axis and y-axis. Okay, we have conveniently put our x-axis like this and y-axis like this. What if I change my x-axis and y-axis basically like this? Okay, where this line is actually parallel to the x-axis line. So if I put my x-axis and y-axis like this, then it becomes a straight line parallel to x-axis and only x is changing. So whenever there is a motion involved, please look at and see whether just by adjusting, aligning our x-axis and y-axis in a different angle, is it possible to make it a 1D motion. If it is possible, work with 1D motion. If it is not possible, then you have to go with the 2D motion. So that's what we learned from this. Okay, let's move forward. So this is 1D motion. Now, what is projectile motion? Which till now talked about only 2D motion, 1D motion. What is projectile motion? Projectile motion is something that happens when you actually under the Earth's gravity you throw something. So you can see you are actually sending an arrow using the bow. Okay, and that will not go straight like this. It will go in a path like this. So such a path which it takes, it is called projectile motion. See, you are throwing a basketball into the basket. It is also going to take that path. and you simply throw a stone, which takes the same path. You kick the football, it takes the same path. So whenever you are basically throwing something in the Earth's gravitational field, it tends to take a path which is called as a projectile path. The word itself is project something, okay, and it will take a projectile path. That is called a projectile motion. So it's a specific case of a 2D motion which has certain characteristics. Let us see what are the characteristics of the projectile motion. Okay, so now let us look at very simply what are the features of a projectile motion. I am going to basically show you again x-axis and y-axis, and I'll show the ball. So let's say the ball goes like this. Okay, so this is what we call a projectile motion. It takes the path of something called as a parabola. Okay, it takes the path of a geometric entity called as a parabola. Okay, so such a thing is a projectile motion. Suppose now if you actually kind of stop it wherever you want. Okay, let's say I am going to basically stop it somewhere here. Then if I see at that point in time, anywhere, stop in the sense a snapshot, okay, to take and see, the ball actually is moving in two directions. One is in x-axis, another in y-axis. It's during the initial process, it is going up, and in the later, after the peak is reached, it is coming down. Okay, so that is the y-axis movement. It is coming down there, and that is the x-axis movement going in that direction. So the x-axis movement is actually no force is involved, in the sense that once you throw, after that it has certain velocity in the x direction. Okay, there is nobody attracting it on the other side or nobody repelling it from the other side. Okay, if you neglect the the frictional forces of air, wind, etc. Okay, in such scenario there is no force in the horizontal direction, but vertical force is always there. Vertically there is a gravitational force which is always pulling it down. So one direction there is no force, another direction there is a gravitational force. Okay, so this gravitational force for all our practical problems is a constant force. Okay, it's not a force that is varying. Actually speaking, the gravitational force varies slightly when you move away from the earth, but its variations are so simple, that so small, that gravitational force we can say is constant for our practical purposes. Okay, for all our practical purposes. Now, wherever there is no force on the horizontal side, we know from basically Newton's laws of movement, Newton's laws of motion, we say that it is constant velocity. So no force, constant velocity. Which law of motion is that? The first law. When there is no external force, a body continues its state of rest or of uniform motion. The uniform motion, that is constant velocity. Okay, that is basically the first law of Newton. What about this one? The gravitational force. It's a constant gravitational force. Hence, there is a constant acceleration. Whichever direction force is there, the same direction acceleration will be there, and it is proportional to the force. The force is constant, so acceleration is constant. So that is this. So now a ball actually is moving in two dimensions, in x dimensions, and in y dimension. In the x dimension it is constant velocity, in y dimension it is constant acceleration, and such a movement is actually our projectile motion. So projectile motions, this is the real feature of a projectile motion. So 2D motion can be solved by applying actually Newton's laws of motion separately for x-axis and y-axis. For two different axes. The x-axis basically it is going with no force, constant velocity. You can go with basic equations, and y-axis separately you can deal with. So how do we deal this with separately? Only difference is that only important factor is, even though you deal with them separately, it is actually on the same ball. So hence the time parameter is going to be constant between these two aspects. Let us see how to do this. Okay, once we understand how to do this, then you can apply it in various circumstances. So let's start with a simple case of understanding how to apply Newton's laws of motion. NLM means Newton's laws of motion separately for each axis. Okay, so this is my, let us say, earth, ground, and the ball is there here, and that ball actually is now going to take the path of the projectile. Okay, this is called a parabolic projectile path. Okay, so now when it is taking a part of the projectile, when that means it has to be basically launched from here. So when it is launched from here, it has to have a certain initial velocity. So let us say this is our initial velocity, okay, 10 meters per second in this direction, not vertically, not horizontally, in some angle. So what is that angle? That angle, let's say, assume that it is around 60 degrees angle. I'm going to launch it. Okay. So now this is the single information we have at this point. Okay. Now what happens to this ball? I said that we can actually deal with it in two different axes, as separate problems. Okay. Now I'm going to do that. So I'm going to take two balls. Okay. One going up and coming down, other going horizontally on the left to right, and I will try to analyze their motion. Okay, how do I do that? But first of all, I need to know what velocity with which it is started its motion on horizontal axis, and what velocity it has started its motion in the vertical axis. So I need, instead of this angle velocity, I need a velocity which is horizontal and velocity which is vertical. How do I get that? So what I will do is I use a trick. So if you know vectors, it is somewhat easier. So now, if you have at 10 meter per second means I will write a 10 centimeter line, okay, at an angle of 60 degrees. And after drawing that, I'm going to basically draw two lines, one vertical from there, and horizontal from there. Now these two lines I will basically join from the initial point. So I will measure this line, horizontal line, and I will measure the vertical line. And these are called as horizontal component of velocity and vertical component of velocity, in the sense that two independent balls can be thrown like this with the same velocities, and they behave in the similar way as a single ball going there, in the sense of how much height it is and how much distance it has traveled, in that sense. Okay. So now this I measured it to be around approximately 5 meters per second. This I have measured it to be approximately 7 meters, 7 point something. I will take it as 7 meters per second. Now, what I'm going to do is, I'm going to take two balls. One ball going from left to right, another ball going up and coming back. Okay. But I will keep the time very, very constant. In the sense, time of both of them are similar. By that time, this ball goes and touches that point, end point. This other ball will go up and come down back to the ground at the same amount of time. That is what I am going to consider now. So with this 7 meters and 5 meters, that's what going to happen. Okay, let's see. You can see one ball going there, other ball going up and coming down, and by that time it reached that point, this reached back the original point. Okay, so that means by that time the ball has reached from left to right point. Okay, the another ball has gone up and come down. So that is exactly what has happened. If you see that by the time it reached that point, the same ball actually has gone up and come down. So these two different axis problems can be solved separately. Okay. So what we are going to do now is that in this direction, you can very clearly see that there is a force. Okay, gravitational force gives an acceleration which is 9.8 meter per second square. That means the ball which is going up suffers a retardation of 9.8 meter per second square, means negative acceleration. While coming back, it actually gets the acceleration of 9.8 meter per second square. Whereas the ball which is going to the right, from left to right, goes at constant velocity. Okay, I'm just neglecting the air friction, etc. Constant velocity. Okay, so we can solve this problem. So now the problem for me is to find out, let us say, what is the range. Can we calculate how much distance it has traveled? How do we go about calculating this? This is called calculating the range of your projectile. When you throw the projectile, where does it reach finally on the ground? That is called range. Range is horizontal distance. How do we calculate that? That is very simple. Think about it. You have a constant velocity, something is going. Okay. You want to calculate how much distance it has traveled. What do we do? Distance traveled is equal to speed into time of flight. That means speed into time it takes to go to that distance. Okay. So I will call it as speed is 5 and time is t. So we don't know the time. Okay, just call it as t. 5t. Okay, but that is not the range we want. We want in terms of meters. So if we somehow know t, okay, how long, then we can actually calculate the distance very easily. But to know the time, okay, how long it traveled on the horizontal direction, so we know that it is equal to the amount of taken for this ball to go up and come down. So let us calculate that t to go up and come down, how much time it took. So that will help us substitute that t here and get the distance. So how do we do that? Let's take for example going up scenario. Okay, going up scenario is what we know. We can use certain kinematics equations that we have learned. So one of the equations that we have learned is v is equal to u plus at. It's a straight line. Okay, and this equation is giving us an ability to find out t if you know v, u, and a. Okay, do we know v, u, and a? Let's see. Okay, u is initial velocity where it is thrown up, which is 7 meters per second. Okay, and we also know u, which means it reached up the point there, and when it reached the peak, it actually is 0 velocity. So v is 0. We know that. Okay, and a, that acceleration, is 9.8 meter per second square. But I have taken here minus 9.8 per meter per second square. Why is that so? Because as we have discussed about the negative acceleration, if the velocity and accelerations are in opposite direction, we can take one of them to be negative. So I have taken velocity in the going up direction and acceleration is coming down direction. Hence, acceleration is taken as negative minus 9.8. Okay. So now I will use this and substitute it. What will come? So for basically t for going up, okay, when you want to calculate t for going up, that will be v minus u divided by a. Okay. So which is nothing but v is 0 and u is 7. So 0 minus 7 divided by minus 9.8, which is nothing but 7 by 9.8. Okay, so that is the second. It is less than 1 second. 7 by 9.8 seconds. That is the amount of time it takes to go up. Now, what is the amount of time it takes to go down? Okay, by symmetry, one can actually say that it will be almost, it will be exactly the same amount of time. Okay, but however, let's just calculate here. Coming down actually is again we are raising the same formula, and we are assuming that initial velocity is 0. We know we are assuming that final velocity will be v, because it is the same acceleration, okay, and same time. So we will simply say it is the same equation worked in the opposite direction. So where u is 0 and v is 7 and a is plus 9.8, because you are going in the same direction, velocity and acceleration are in the same direction. So now if you use these things and calculate, you will actually get t for coming down, which is actually also equal to 7 divided by 9.8 seconds, so less than 1 second. So what is the total time taken? Going up and coming down together is total time. Time of flight is actually equal to t for going up plus t for coming down. So both if you add, this will be 7 by 9.8 plus 7 by 9.8, which is 14 by 9.8. So once you add, that is the amount of seconds. So you are going to the ball actually takes to go up and come down. Okay. Now the same time the left to right horizontally it has moved. So that time if I substitute into my original equation, distance is equal to speed into time of flight, I will get the range, that is the distance traveled. So the range is simply equal to 5 into t. T is 14 divided by 9.8, and you get basically somewhere around 7.1 meters in the range that it has traveled. So this is how you can actually solve a problem in the two-dimensional case of a projectile. In the case of a projectile, we need to basically look at horizontal and vertical axis as two different axes basically. And in one axis, in both axes you deal with in terms of what is the velocity and acceleration, what is the velocity and acceleration in each axis, and time you can take the common for both of them and work. Okay. So this is basically how you can apply. Now, let's also find out in the case of similar case, for example, if I want to find out something slightly different. This is how exactly it worked. Okay. So now I want to find out something slightly different, which is calculating the height. can I calculate the height? Of course, because calculating the height doesn't actually even require horizontal movement. Whatever may be the horizontal movement, calculating the height basically is independent of that. Okay. So we can simply calculate as a vertical going up. Okay. So how do we calculate? We go with 7 meters per second as our initial velocity, and we also go with g as 9.8 meter per second square negative. Okay. Now we will use a different formula this time. We will use another kinematic formula which is called v square is equal to u square plus 2as. So why do we use this formula? Because we know v and u, and we know acceleration. So three variables are known in this. S is the height it is traveling, so we can calculate the fourth variable. Okay, we just need height, we don't even need time, so we can use this formula. So now how do we do that? We just substitute it. To calculate, you know, u is 7, v is 0, a is minus 9.8. So we can easily calculate s is equal to v square minus u square by 2a. Okay. So once you calculate, you get the height to be about 2.5 meters. That is why you can calculate the height it has reached. So we have kind of got an understanding of how to use the two-dimensional problem, how to solve by actually treating two dimensions independently and working on it. Okay. So now let us look at the next step is our circular motion. Okay. Now we have completed the projection motion, projectile motion, and we will get into circular. But however, please understand that the circular motion, the projectile motion, I have shown you a very typical simple scenario, but it is possible that it can get pretty complex. And then you actually throw something on an inclined plane, and where does it hit? So such questions when they come, you have to really deal with which is the what is the horizontal acceleration, what is the vertical acceleration, all that. Okay, and we have to incline the x and y axis and see. So all those things we may have to do. But before going there, we will try to understand what is meant by circular motion in our next class. Thank you.